This is the What's Hot Next Year panel, and we have three distinguished panelists from a couple of different areas in computing to tell us what they think the future is going to look like. So I'd like to start with an introduction of the panelists. Could you each tell me who you are, what you do, and what you're most excited about changing in the next couple of years? We could start at this end of that end, either way.
Well, I'll start. I'm Jacob Farmer. I'm the CTO for Cambridge Computer, and I work in data storage. And I don't know, I've been doing that for about 20-something years. And I kind of a neat job. I get to both be responsible for actual projects, but I spend a lot of my time just yuckety-yucketing with industry analysts and with the executives of some of the larger storage companies, and as well as a lot of the startup companies. So I kind of sit in a little crossroads of at least the commercial side of data storage. And I think that the hottest things for next year is only a couple of weeks from now, but the hottest things in the imminent future, I think we're seeing various incarnations of solid-state disk are going to replace spinning disk, or at least augment it dramatically. That's probably the biggest one. And then I think that the whole cloud thingy has a lot of implications for storage. I think the killer app for clouds, at least for enterprise computing, is going to be hosted disaster recovery. And I see a lot of startup companies working on that with some pretty convincing and intriguing models for how they would do it. So I think those are probably the two big ones.
Okay, I'm John D'Ambrosia. I am in the Dell CTO office. My title is Chief Ethernet Evangelist. Basically what that means is I'm in the crossroads of all of the Ethernet standards from a physical layer sense. I have other team members who cover all of the protocols. And I think what I see happening exciting is the near imminent deployment of 10 gig in mass volumes, and what that's going to mean to networking across the board, both for 40 and 100 gig Ethernet. And in terms of what the hottest thing is, unfortunately, I have to say it's probably the chips that are driving all this stuff right now, as well as the optics. And we need to cool that down. And I'm involved in a lot of efforts related to that.
So my name is Kris Buytaert. I'm one of the guys that initially started DevOps Days back in Europe. My day-to-day role is I'm the CEO of what Luke nicely called yesterday a boutique consultancy shop on open source back in Europe. I've been doing DevOps evangelism for, almost 5-6 years, since before we had the term. And what I see for next year is that lots of enterprises in Europe, at least, if I talk to CEOs back there and CIOs back there, they're trying to improve everything they're doing regarding deployment, monitoring, measurement, scalability, and all that stuff. And it's moving out of the Web 2.0 world and into the enterprise.
So it seems like in each of the cases, you were all talking about sort of techniques that are becoming, or technologies or techniques that are becoming sort of more mainstream. And so in terms of the sort of DevOps philosophy or lifestyle, right? These are techniques that people are really starting to adopt. And in terms of network, you see 10 gigabit really sort of arriving for real, right, in volume. We've had it sort of in the experimental stage for several years.
Well, it's been real at a networking stage, but that networking is not...
They're not to the nodes, though, right? I mean,
well, it depends on on your architecture itself, right? I mean, in aggregation nodes, 10 gig has clearly made a hit.
Sure.
But down at the host station, whether it be the servers or your desktop or whatever end station it is, we're seeing that happen.
Right. And then in terms of solid-state storage, this is a technology that's kind of been around for a little while, and people have been figuring out what to do with it.
If by a little while you mean 20 years, yes, it's been around for a little while.
I guess when I think about it, I think more in terms of commodity, right? And so in the commodity space, solid-state's really been around for maybe 5 or 6 years in sort of...
Well, I used to have these things in my motherboards called EPROMs, which are actually flash memory. So still, I'd say 20.
Right. Oh.
I'm just being difficult. I'd say, yeah, what's happening is that they're getting bigger, faster, and cheaper, and more reliable.
And so as all of these technologies that have sort of been incubating for a while arrive in mass volume in a very commoditized fashion, How do you think the industry is going to change for people that are trying to make small to large computing systems work?
Well, all right. Well, I'll go first. So I think I think in the small to mid-size enterprise, data storage is really difficult in the sense that you have the same problems that a large enterprise has, but you have less resolve to throw money at it, and you probably have less dedicated personnel to figure out something complicated. So one of the innovations that's happened in the small enterprise that then has been creeping its way up into the large enterprise is the virtualization of individual disk spindles. That is, having some magical disk array that doesn't make you have to worry about how you group your hard drives together. And the big win there is that you don't have to really understand performance, and you don't have to monitor performance. You can kind of throw all your servers into a pool of disk, and if it's too slow, that's just because you don't have the money for it. And if you have some more money, you buy your way out of it. So there's a whole balance of kind of striking the balance between performance and capacity and cost. And I think all that will go out the window as solid-state storage devices get cleanly integrated into enterprise storage platforms. And that'll happen as a function of commoditization and time for the engineering to mature. So any startup company that's building a storage device today has integrated solid state into it very thoughtfully, and they have enormous performance advantages over a traditional array. And I think, again, all this stuff has to bubble up to the surface. It has to have its tipping point / go viral, whatever you want to call it. But I think a lot of the complexity of managing storage will just go out the door once these devices are integrated. Just as one other point of reference, a hard drive, a 15K hard drive might do 200 IOs per second, and a relatively inexpensive solid-state device might do 50,000. So it's just really figuring out how to balance the capacity, use the capacity wisely, either as caching or as tiering or some combination of both.
So my question to that is speed really the big question people are looking for? Because lots of my customers are looking at, I want just to have storage somewhere. Even if it's on the other side of the ocean, speed doesn't matter for them. They just want safety.
No, but it's one of the harder problems to solve is just managing performance against capacity. And a lot of the cost goes into buying a system with the appropriate number of spindles. Even things like snapshots and replication are sometimes bound by the underlying disk performance. So I wouldn't say it's the most important thing that touches storage, but I'd say it's the most innovative thing happening in storage is solid state. If nothing else, to your point about having buckets and buckets of disk anywhere over the ocean, there is this whole cloud thing going on, and the cloud is sort of very high latency, eventual consistency. And it is possible to have a caching device sitting on the edge of the cloud in multiple locations where you're synchronizing file systems. But then you're doing a lot of very small granular I/O, and there again, having solid state at your disposal allows those operations to happen fast enough and reliably enough to take advantage of the cheap, deep sea of storage out there.
And I don't fully agree that speed doesn't matter. I think it's always about the user experience in terms of whatever you're trying to do. So if an application holds somebody up from using it, it's not useful to them. So there are aspects like the offsite storage where probably not as big of a deal, but if you're running an application somewhere that you have to go get off the cloud, then it's a different problem altogether. So
I sort of feel like a more pointed version of Kris's question is when are systems, whether you're talking about networking or storage or CPUs, when do you think that they get fast enough, right? I mean, I was struck recently, I was looking at my laptop, and I have an SMP laptop with 8 gigs of memory and a solid-state disk in it, right? And it's this, and this is a completely commodity device now. And if you told 10 years ago me that I was going to be carrying around this device, it would sound completely insane. And cell phones are getting there, right? And so, at some point, you get to some sort of point of diminishing returns for a lot of applications. And do you, as you guys are dealing with customers,
I think at least it's related to storage, is that storage is so slow relative to everything else, and it has been for so long, that the whole ecosystem has been designed around how slow storage is. I have this really fun little slide I use to show the relative performance of CPU cache, RAM, and storage. And I do it by making an analogy to weight, where if a CPU is a can of Coke, a level 2 cache is a bowling ball, RAM is a St. Bernard dog, and then disk is the Eiffel Tower. And that's the relative performance differences. So when disk catches up to everything else, it just enables a lot of other things, I think, to run more smoothly or easily. And it's such a huge, I'm using all the cliches, it's such a huge paradigm shift for data storage. We've been stuck with really slow devices and tiny little caches. Suddenly we have this dynamic range between that St. Bernard and the Eiffel Tower. That's the potential for the SSD choices. And they can come in every mixture of capacity, reliability, performance, and cost, and just shaking up the industry.
So you're focusing in on the speed, but in some of the other questions and debates that I've been having with people, really looking more at bandwidth, I've been given the stat that in 2015 we'll actually produce more data than we can store. And as we start to look at machine-to-machine communications, we start to get into whole other issues, like how much data do we need, what data do we need to have, where do you back it up? If you have all of these terabytes or exabytes of data, is storing it somewhere across the ocean acceptable? I mean, it does. I think there's a couple of problems there, right? There's the performance aspect of it, but then there's just the capability to actually store everything that we're going to do.
Yeah, I mean, maybe the best way I could reconcile that to what your point about 10 gigabit is that the faster we can move data, the faster we have to be able to send it, and the faster we have to be able to catch it. And currently the way you send data fast is you aggregate a whole lot of spinning hard drives together. They're heavy, they draw a lot of power, they're expensive. If that gets all shrunken down into a small solid-state device, that might enable that data movement to happen faster and better. It may also create, who knows, maybe it'll create additional competition with the hard drive marketplace to retain its relevance by figuring out how it gets even bigger and more efficient. I mean, it already wants to do that, but maybe a little competitive pressure will drive it harder.
Well, I think that in itself is the ongoing trend that we're seeing across everything. Everything is getting faster. It has to, and it has to have more capacity because we as humans keep finding more ways to get data, use data, and we want to have it at our fingertips. Your question about when is fast enough, I don't know how to answer that when I don't notice it. I remember back in the old days when I had the modems, somebody sent me 50 meg of pictures. It took 6 hours to get off the modem. My wife was yelling at me the whole time for tying up the phone line for that long, but I needed them because I was on a trip. I myself would never have thought to send 50 meg of pictures. Nowadays, it's like, yeah, whatever. But if I could download more movies quicker, would that be beneficial? I mean, right now I have to start a download on iTunes, and it takes a couple hours where I'm at. A half hour would be preferable. 5 minutes would be even better.
So you were talking about data growing and needing more bandwidth. The only thing that's never going to get more bandwidth is the human brain. And to me, that's one of the real big challenges in the future, that how will humans be able to parse the data and make relevant things from it? So I see a huge adoption in BI tools. Open source BI tools are really growing. People are logging in their infrastructure so much data, but are really not using it. So part of DevOps is getting the data that's visible, that's over there, and actually turning it into information. And you need storage for that, you need bandwidth for that, but you also need people capable of interpreting that data. And that's not a technology problem, that's a culture problem. That's something we all need to learn. So if you're bored these days, I think statistics and all those things, that's very good stuff to spend your time on.
Yeah, but by the same token, the bandwidth that I'm using is not limited by my human brain, because I can kick off an operation that's consuming bandwidth and I'm not doing anything. I can back up, I can load presentations onto a hard drive somewhere. It's a click. I can download at the same time, download a movie. It's a click. I can be on the phone, and then I can be IMing, and then I can be using some applications.
But it's still data, not information yet.
I'd validate your point. I find that I'm having a hard time remembering all of my data and making use of it. In fact, I have to forget stuff to make room for new stuff.
So it depends. On an individual level, your useful data is the amount your screen can hold in front of you, right? It's all you can see at any given time. That's the only thing I need to get to the endpoints, right? So from an international or getting data to the end user, anything more complicated than the the resolution of the screen in front of me at 60 hertz, I can't take in anything more than that. So that's the bandwidth I need to the end user. Everything else can happen in a central point with as much bandwidth as it likes. So once you get out from the data center, that's as much as you need, right? As the screen resolution goes up, that number goes up, right? And we're seeing this on mobile devices. If you can fill the screen on a mobile device, then that's all the bandwidth I need for the mobile device. Then we're down to latency, right? The horizon you guys are talking about is very, very short, and it's all incremental change, right? If we're looking at future, is there anything which lowers our power needs significantly, right? That's the key on how big our data centers can get. Is there anything that lowers how much heat we're throwing off? That's something reasonable, right? Everything else is very small incremental change, which, I don't know, wired for the last 6 months would tell us.
So in terms of specifically, this is going to be addressed towards the hardware guys. What are the things that are going to be coming down the pike in terms of improved power efficiency? Because that does seem to be the limiting factor for more and more people these days. I mean, John, you'd mentioned needing to bring down the power budget of optics and things like that.
So there's a lot of things that are happening right now. I mean, from a 40 and 100 gig perspective, just the architectures of the devices and where we put things and pulling things out of modules and moving them elsewhere, going from 10 lanes to 4 lanes and going faster. All of these are going to be incremental power improvements. But I have to say that there are lots of things that we can do in hardware. We can do things faster. We can go into low power idle modes if we're not using it. We can do things smarter. One of the trends that I've been hearing, and I'd like to hear from colleagues here, is that it's not necessarily just the hardware, but a lot of the software. I was at a conference last week where people were talking that software development and improvements could actually hold a lot of key to power improvement. And I don't see the power improvement actually as... The power improvement isn't to save energy per se. It's in order to fit more capacity into that given power envelope, right? So ultimately, we're not saving power.
Oh, it's not a green argument at all,
right?
It's a
like,
question of what do we get for 20 megawatts?
I need to put more capacity into that system, right?
Yeah.
How can I get more out of it?
So, Jacob, what do you think about storage? Do you think
well, I mean, the way my points reconcile back to power consumption would be, well, one is that the solid state, the opportunity to leverage solid state just requires smarter and smarter and more granular tiering and caching software. And once you have that, you can take all the fastest and hottest of your hard drives and you can put those onto low power, low heat solid state storage devices. And then maybe the balance of your storage is sitting on some relatively slow, higher density, lower power SATA drives or nearline SAS drives. And then I guess you could extrapolate that one further, which is if you've really got great tiering logic, then the vast majority of your data could in fact sit in a power efficient data center somewhere over the cloud, not have to be burning the cycles within your own data center.
So if I look at what I'm seeing regarding green data in centers, there's really little adoption apart from really the hosters and the ISPs. Software developers, there's a bunch of research going on. There's tools in the Linux kernel which you can use, and probably other operating systems have the same, but I don't see anybody actually using it because they're not seeing the actual benefit yet. They're not seeing the bill at the end of the month. And as long as there's no visibility for those people on what they're actually costing their users, they'll probably won't be changing that. So,
well, I think that really sort of varies. There are certain places where there are pain points surrounding power. Right now, large-scale data centers are one. High-performance computing is another. That's sort of the area that I work in, and there's a limited amount to drive more power into our data centers. And so to build larger and larger systems, you need to do things differently. And so the sort of around this idea of doing things differently, as 10 gigabit becomes more pervasive, and maybe even 40 or 100 gigabit reaches a host, which will probably happen in the next couple of years in some sort of meaningful way. And as solid state gets faster, how are these technologies going to change how people interact with them, right? You can do qualitatively different things with a high-quality 10 gigabit interface that you can't do with gigabit, and you need to interact with it differently. And the same, I think, is even a better argument for storage, where the performance of operations really sort of make different things cheap on solid-state storage than were cheap on disks. And so how do you think that's going to change the way that we interact with this hardware over the next couple of years?
Well, the first thing that popped into my head was I was sort of processing your question and trying to think about how solid state helps us mine our information better. And the best example that just came to mind was I've been using this fun little Windows application called Zobni, which is inbox spelled backwards. I don't know if anybody's ever seen this thing or not. But what this thing does is it indexes all of your email, and it builds like a little social network out of the different email conversations you have, so you can easily find people by who you converse with and which people are related to each other, and then you could do text searching and whatnot. And as I became addicted to this software as the only way I can mine the 20 gigabytes of email data sitting in my inbox, I have a hard time with folders and tags and whatnot. It didn't work on my desktop computer because I had this SATA drive that it came with, and I ended up buying myself a shiny new laptop that had a pair of RAID 0 to SSD drives in it. And now it all works like a champ, and also that laptop happens to get an extra hour or so of battery life out of it than the old one did. So I think it just comes down to we can, things like indexing and really sophisticated indexes can be enabled by solid-state storage, again, because suddenly disk storage is capable of doing things at a performance level it could never do before. And so I think really it's just as simple as we'll get more disk performance, and more disk performance will let us read through information or sort information faster.
May I throw in a question? So in terms of paradigms, I'll use the word too, a lot of the conversation still hangs around with, well, if you take into account the cloud doing stuff, but we're still tending to think of, I'm running something on this thing that I'm talking to and processing data. There's these huge amounts of data which we can pull out very quickly and we can ship quickly, but relatively, we're throwing around terabytes of data casually. And I'm thinking that people are forgetting how much data a terabyte is, because it's sort of a lot of data. Given the decreasing number of computer architectures out there, x86, 64, whatever, there's a huge amount of that stuff. The storage has got a lot of that processing in there. Do we see changing paradigms where the processing of data is going to not necessarily be where we run it locally, but we actually just ship off code, and the code itself goes off and maybe runs wherever the storage is, or what? Just as a thought.
So I know that there's a lot of activity both in the sort of data mining space and in high-performance computing to try and map that locality of computation to where the data actually lives. There was a talk yesterday from the folks at IBM working on GPFS, and they are starting to expose locality information for disks so that you can match your computation with the physical location of the disk so that you don't need to transfer it over a network and so forth. I guess the longer-term question is, so far everything that's been discussed here has been incremental improvements on what we have, right? So widespread adoption of 10 gig, which is really, 10 gig has been with us for 5 years or so in some form?
9 years.
9 years? Oh, okay. So, and solid-state storage has been with us in a variety of forms for a long time, and it's gotten commoditized recently, and these processes in terms of DevOps have been developed in largely a bottom-up fashion, right? And so people have been doing aspects of these for a long time, but not necessarily in a coordinated fashion. So what are the things that are going to be exotic and different in a couple of years, right? We can sort of extrapolate and say, well, we're going to have more storage, and we're going to need to move more bits around, and we're going to get more organized about the way that we analyze our systems.
So the title of my talk yesterday was "The future is already here. It's not evenly distributed yet." And I think we're not really going to see big shifts.
I agree. I think it's more evolutionary than revolutionary. We just keep doing things faster, smarter, more of it. I think probably the the interesting point that we've gotten so far out of this is the human element of things is starting to have a very big effect on it. I don't think either of our opinions are wrong on it. I just think that as individuals we use things differently. And I think getting systems that can take care of that and work from that perspective could lay a lot of any potential revolutionary type things to come.
Well, I think my perspective on that would be that in the grand scheme of computing, the changes in storage will probably be evolutionary rather than revolutionary. Within the confines of the data storage sector where I work, I think that the changes are in fact somewhat revolutionary. When we'll see very, very different looking storage devices in the next few years than we have today. And we've already seeing this. We're just not seeing them mainstream. But I've had a lot of clients that have been able to dramatically change their businesses because they're able to do disk performance at 10, 15, 20 times faster or with lower latency than they ever could before. So I think just in the narrow little box of the data storage industry, solid-state storage is a huge game changer.
I think one thing I could say, you put a time frame on your question, and I think that's part of the problem. For where I'm seeing things right now, I think from an Ethernet perspective, I see a way to 400 gigabit Ethernet. It's not the prettiest, but I see a way there. When I look at terabit Ethernet, where a lot of people want it, I don't see a way there. There's gonna have to be some things that are gonna have to change, or we are gonna have to have a paradigm shift in all the interconnect technologies. Maybe we finally do go to more of an O world rather than an EO world.
So can you be a little bit more specific? Are these changes in the way that the hardware needs to be designed, or in the way that the software needs to interface with it, or
Just in
both?
the basic way that you carry information across any sort of infrastructure, whether it's copper or whether it's optical. We are approaching those pesky laws of physics. Electrically, right now, we're looking at 25 gig. As we look to going beyond it, there's a lot of us shaking our heads. How are we going to do this? And the ways that we typically do it, well, now we're starting to have to worry about material properties. We have to worry about power as well. And then we have to worry about latency. There's a lot of constraints coming all together that, looking ahead to that next speed jump and doing it at the potential cost targets, I think we see a paradigm shift happening, but not in the next couple of years. I think that, and that in itself is just part of evolution, right? Because I'm saying that right now, but in the next few years, there may be changes that are less revolutionary and become more evolutionary because of the time frame that we put on it.
No one has talked yet about pervasive computing. As we get closer and closer to a world where there are sensor networks deployed all around us, where there are distributed computing nodes all around us, where there are multiple devices for every person that is consuming the services that they're providing, what are the changes in storage, changes in power, changes in networking, changes in the way that these things are deployed and managed when you have vastly more compute nodes in the physical spaces around us than we have today?
I think that's a great question, and I think it's not just the sensors. I think networking technology itself is going into places that we hadn't originally participated. In my talk earlier today, I talked about how there's a call for interest to start a project to bring Ethernet into automobiles. And the question that I pose to people is, does this make this part of your network then? Does the automobile become just another module that you're going to have to worry about? So I think that is a real question. Now, I'm not well versed in all of the sensor interconnect. My understanding is limited that basically can leverage any of the wireless or wired technologies. How those actually work into networks, I think is an area of development we're going to see a lot on. And that doesn't bring up just the storage problems. It brings up the power problems because these sensors are all going to require power as well. And I think that goes to the other question that we were having about, we have to store this data, and then we've got to get information out of it. And I also would raise what data, if we have these sensors, are we going to be legally bound to keep? So then you got legal issues as well that come into it. So that sounds like a future job security field to me.
So when you have a bunch of sensors out there, the next question then immediately becomes from you've got data, but how to turn it into information. I saw somebody earlier this week having an iPhone app where he was taking pictures and he was actually expecting that the company that was providing him with the app was doing data analytics on that, and that they were going to use that data. And he was disappointed because they weren't doing that.
I'm taking a pass on this one. It's
Well, I think there's cool apps that come out of this as well. Maybe if there's sensors out there that indicate, you can use that for traffic, right? I mean, we're doing that today. So it could change a lot. I think the basic underlying interconnects and how we do stuff, even in some sense the basic software is going to be evolutionary. But I think how it all comes together and the applications that get created in the human mind out of these tools are going to be what's truly revolutionary.
So more and more we're recognizing something that people at this conference have known all the time, and that is that system administration is a cooperative process, and it's really a team sport. And one of the big trends lately has been social networking. I'm wondering how you see either the actual applications or just the principles of social network apps being applied to system administration and technology.
So who's not using an IAM server already for his internal sysadmin team? Well,
I sit next to the one other guy that I work with.
We use a MUD.
are we going to use Facebook for that? I don't think so.
I don't know, could you do you see a day where we will friend all the machines we're responsible for managing, and they'll post when they are having a broken hard disk?
So
My Jenkins instance already reports broken builds on Twitter to me, but
yeah, I mean, this goes to exactly the point that I just made. We're all laughing about it, but 40 years ago we were probably laughing at Star Trek with the doors opening up by themselves. Now we take it for granted that it happens. Why not? I think that's the better question. Why not? Why should we be limited? If somebody figures out a way to do it that reduces cost and saves money or makes money, they're going to do it.
I have IRC bots that tell me, I could ask them what time is it in the local time of a particular coworker. I have IRC bots that tell me when a silence is about to expire on our, if we've silenced an alert, all that kind of thing. But it's not, these kind of things aren't pervasive. Let me change the subject, totally different question. One of the most annoying things in my career is the speed of light being fixed. I'm really upset about this. I'm waiting for people to fix this for me.
They are working on it.
I thought there was a certain project that just showed.
did you try sunglasses?
I've tried new glasses. That didn't help. So latency. What can we do about latency? And in particular, the principles that Jim Gray laid down that really became cloud computing. One of them was you need to put the computation near the data. And we've followed that by saying, well, we'll put everything in the cloud so the data and the computation is right there. But my cell phone has more compute power than I ever imagined that I would personally have. So should things shift back and forth, or what do you see the trends being the next couple of years?
Well, if you look at Europe, Europe was never a big Amazon user, at least not on corporate level, but I already see some of our US customers moving outside of the cloud again, just because they want to have their data local. They want to have their power local. That and combined with the absolutely enormous Amazon invoices they got. So there definitely is already a trend of getting data back out of the cloud and building it local, whether it be for performance or privacy reasons or for legal reasons.
What about on my body? I mean, I have gigabytes of storage on my body. So.
Okay, I don't want to go there.
Well, and as a related thing, this is a good point that there's this process where people are moving things in and out of the cloud, and they haven't really determined what the right balance is yet.
But that's everything. There's all the pendulums that swing back and
absolutely.
forth, right? And each time.
I think that the one important thing that had sort of appeared, I think, in a major way first in the cloud was the idea that all of your major services should be behind APIs, right? And two of the areas where this has lagged behind the most, I would say, is on the network side, though it's improving, and on the storage side, right? I mean, when you buy a network device, it's generally running some sort of proprietary system, and there's no standardized ways to interact with it. And the same things largely apply to the management of storage, though the protocols for access of storage have been standardized for a long time. And so, do we see any movement in terms of improvement in terms of being able to interact with these devices in a more standardized way or behind programmatic APIs?
I really would like to see movement there, and I remember Tom writing a blog post somewhere about that too, about 2 years ago. So I've been quoting him on that, and one of the things is I want my machines to be able to configure networking and storage devices from an API, and I'm not seeing that yet. So I'm really looking forward to that.
Well, the challenge has been in the storage industry is it's a very, very competitive industry, and the vendors don't really want too much interoperability because it makes it difficult to lock in your client for life. Almost every standardized storage management technology is a least common denominator thing where the vendors always have something better that's only available through their tools. So it's just been very difficult to find any one way of doing it. Now, I think with the movement toward clouds, that can't be done without standard APIs. I mean, the closest thing to a standard API right now in the cloud, I think, is Amazon's S3, or there's a SNIA standard. I think it's like CDMI or something like that. And but even those are slow to being adopted. Vendors keep preferring to come out with their own unique approaches. But I do think there are efforts. I think when it comes to sort of the bulkier, long-term, bigger storage, those kinds of things will be more self-provisioning because they kind of need to be. You need to be able to just keep on growing and growing and growing. For enterprise storage, I think it'll remain silos and proprietary stuff.
So I see a lot of questions from people wanting to move away from traditional storage and go to cloud-based storage, but hosted locally. And I see a lot of movement going on in different cloud file systems like Gluster, MooseFS, ExtremeFS, and all those things. SEP is also one of the ones that lots of people are looking at. Today, there's, in my mind, not one that's actually suitable for production yet. But I hope next year that that's going to change. And that might be one of the things that is going to near future where a lot of people are working on.
So, John, do you see any movement in the network space? I know there's a lot of excitement around OpenFlow, but that hasn't translated to vendors actually starting to support it.
Yeah, I think that's a good point. I was going to bring that up. There is a lot of discussion about that. And as I pointed out earlier, there's a lot of discussion just in general about software and software-defined networking. And I don't know if the movement is such that you'll see stuff next year. The movement may be more that you see more movement towards an organized movement in itself, see more people in the industry as a whole move forward.
We've run out of IP4 addresses, so I expect we'll see a lot of IPv6 over the next year. However, I was disturbed to find out in the course on IPv6 that their plan for routing this stuff was strictly locally hierarchical. There's the world, there's the continents, there's the countries, there's the ISPs in the country. And the multi-homing, which it gives you some choice, is a research topic that seems to have been an afterthought. Is that going to have political implications in the next year or a little bit further out?
Everything's political.
I think the answer is pass. A lot of the discussion here, someone was commenting the other day that they hope to see a lot more discussion about IPv6 over the next year or two because of address exhaustion, and there was a snarky response that perhaps we'll just be seeing a lot more discussion about high-performance NAT, right? And I think it's sort of unclear what's going to be happening.
So, Narayan, I don't want to let you off the hook. There's configuration management, I think, is obviously a big topic and always has been for Lisa. in the workshop on Monday.
It all blurs together.
Yeah. I thought orchestration came up as a pretty hot topic about, okay, we can configure systems, now what? So I'd love to hear some comments, especially from from the hardware side. I mean, how does this all hook together? I mean, when we start trying to write software that organizes complex events across our data center, what do we see in the next 1 to 5 years that's going to help us with that software or impede our progress on that software? Where are the bear traps?
The lack of APIs from the hardware vendors, both on networking and storage level.
There are absolutely bear traps all over the place. I think that in terms of configuration management, we've spent a long time optimizing the use case. A lot of the sort of popular configuration management tools, save for CF Engine, which is considerably older, were designed in the sort of 2004 to 2006 timeframe initially, right? And I think that's reflected in their designs, a particular model of what the operations that you want to perform are, right? And the world has changed a lot in the last 5 years. And while these tools still are productive and useful to use, they may not actually correspond to the world of 2015 very well. Not that I know what the world of 2015 is going to look like, but one of the questions that I think is pretty important is we need a very forward-looking sort of process to start now, because it's going to take us some time to get there. I mean, just as it did the last time, we really need to start speculating what the future is going to look like in terms of these components that are going to interact with each other, and what do we need out of these components, and how are they going to talk, and what are the sort of properties that we want to get out of them. Because I suspect that the world is changing, and it's going to continue to change, and I suspect that the change is going to accelerate to some extent. And so when you sort of look at that really suggests that the tools that we have now are going to appear very outmoded in a few years, and they need to start solving different problems. And I think it's an interesting discussion to start with what those different problems are.
In the past couple of years, we've seen a lot of really cool stuff happening with natural language processing, Siri, of course, Watson, and even simple things like test frameworks like Cucumber that use a subset of natural language processing. Where's that all going, and how is it going to make my life better?
Have you read the RSpec book? Well, that's the only way to do Cucumber. So it's not really there yet. There's a lot of work to actually get Cucumber to a point where everybody in this room can use it. So that's going to take a couple of years, I guess.
Well, and sort of going back to the sort of connection between that and the previous question and sort of putting all these technologies together, there's a lot of ambiguity in human language that we kind of deal with imprecisely and incorrectly a lot of the time. And computer hardware is awful dumb, right? And so the areas between the constraints are hard, and so I think we've got some time before we need to worry about robot overlords.
Yep. Personally, I'm stumped as to where natural language processing and data storage overlap. Maybe like format.
Oh no, I would like to write
Snapshot.
a test. If I pull this disk, what happens?
Okay.
That's the kind of tests you want your tests, your QA team, to be able to write. If I pull disk number 4 in this array.
See, I think a better way to do that would be, here I'll go reconcile that back to my earlier points, is that I think that capacity needs to be managed in a super duper redundant way with cheap storage distributed all over the place, and performance needs to be managed by solid state devices, and it all has to be held together with really smart tiering logic. And that all becomes much more possible when you actually have those really fast storage devices and you're able to build big enough indexes to track all the data going up and down, and that probably has to be on solid state storage devices too.
Or in highly interconnected memory.
Or both.
And then highly interconnected memory brings us back to some of the issues in terms of latency, because in order to make those transmissions happen, you got to figure out a way to make it happen. And if you introduce anything that makes it happen and introduces latency, you've defeated yourself.
So 30 years ago, nobody was a sysadmin except actual sysadmins, 10 years ago, a lot of young people were sysadmins for their grandmothers and fathers, small firms, and et cetera, et cetera, et cetera. Today, everybody who has information devices is a sysadmin. Everyone, has to troubleshoot cable modems and has to troubleshoot iPhones and has to troubleshoot Facebook accounts. What are the techniques that are going to be bubbling up from the Aunt Tillys of the world into the sysadmin world over the next couple of years? And what are the techniques from the sysadmin world that are going to be bubbling down into the everyday lives of people over the next couple of years?
Well, as a parent, I find blocking my kids from getting on the computer helps the most.
It's utterly impossible.
I can try. Yeah, and fail. Exactly.
But you said your kids are getting on the computer. My kids are on the iPad. My kids are on the iPhone.
Oh,
They're
exactly.
going to be learning about systems administration the hard way or the easy way, depending on how you look at it.
No, they're going to make you learn the hard way.
What are we going to be learning from
their
them?
human nature is to go and just explore. It just amazes me what my oldest son has pointed out to me how to do. I'm like, crap, I didn't know how to do that. And he finds it. But then at the other extreme, he does stuff in exploration that I wish he wouldn't have done that then causes me 2 days of grief. You're absolutely right.
The FBI shows up at your door.
Yeah, exactly.
So I think one of the things we'll learn from both kids and elderly people is usability. One of the worst things that happened when my mother upgraded her Ubuntu and Unity came along, she was screaming. And she really didn't like it. So she had never used anything else besides her previous Ubuntu desktops, and that for her was the turnoff. She wanted something else.
Wait, your mom uses Ubuntu?
Yeah, she's 70. She never uses anything else. She started using computers 10 years ago.
My mom just writes in assembler. She doesn't waste her time with it.
I hear some Dilbert cartoons coming out.
Well, at the very least, I think your average Joe becomes a backup administrator. Or not, right?
So I think one interesting related thing is as you end up with less skilled people operating devices and debugging devices, that means that the systems need to get smarter about exposing information in a way that's usable by non-experts. Do you guys see any improvements coming down the line, or are the techniques that we're developing for system administration applicable in some way? Is this something that we should actually be thinking about trying to make more accessible?
Well, I think the fresh set of eyes that we're going to be getting with the next generation is going to do some incredible things. They're growing up with this now. I mean, that was a great point. My kid has his iTouch. He's on the computer. The other one's on the iPad, and that's how they're learning. And they're going to get to a point, and they're going to look at this and go, God, this is stupid. Why are you guys doing it this way? So I think that fresh set of eyes and perspective is one of those things that we can look to for the future.
Scary thought.
In that same vein, we do have people growing up with these incredible devices that can do amazing things, and I do see, at least in my opinion, that the education system is kind of leaving it all behind. They're still using, they're trying, but I don't think that kids are really learning these days. The next generation is like I said, exploring. Right. They're not really being taught best practices. They're not being given the history so that they don't make the same mistakes again. And do you see education? I know that there was actually a panel, I think, about this earlier this week that I wasn't able to attend, but education of system administration, and even a basic sense, that you should back up your data. I think there's a lot of kids growing up that the ideas of backup is just, well, what is that? That's something that these nerds do back in the
Back
data
when
center.
I was a kid, I had to swap floppy drives to get my data.
You forgot the snowstorm.
In the snow in my bare feet for 7 miles.
Uphill.
Both carrying ways. A box of bricks. Yeah.
No, but that is a good point, because like my oldest son has all these pictures and he has all these stuff from iTunes. Did you back it up? Huh?
Well, I think that there are skills that may be missing that people will learn through the hard knocks sort of way, right? And everybody makes some kinds of mistakes. But one of the things that I think is fascinating about seeing kids interact with this, with these electronic devices, is that there's a sense of curiosity that they have. And if we can figure out how to keep them curious, that may be enough, right? That may be a big enough change.
Well, they are getting curious, and look at the things that are happening. What was the thing in the news where they turned over some sort? I think it was a cancer cell to the gaming community, and the gaming community figured. I mean, that's the revolutionary thing, right? That in itself, that was revolutionary. I mean, that's mass computing and mass eyes actually doing so much stuff, and the fact that these kids are learning. Maybe it's not important for them to learn all of the guts and all the stuff that we spend our lives up here doing, and for them to use their creativity to make apps like that happen.
Yeah, they certainly aren't going to be comfortable on the command line.
Yeah.
On the subject of backups, Tom and I were at breakfast, and he pointed out that the jQuery website, they accidentally deleted all their files, and when they went to restore them, they discovered the last backup had been taken more than a year ago. So, everything was totally gone. So, if
Did they hear about version control?
If IT professionals can't do it right sometimes, what hope do we have for...
The School of Hard Knocks. School of Hard Knocks,
They
right?
probably won't make that mistake again. Also, as they say, you keep your resume on a thumb drive.
You actually expect LinkedIn to back up that for you.
So it seems like we need to start building smarter abstractions, right? I mean, the idea that an important project has data that they're not backing up and they don't know they're not backing it up. I mean, it's one thing if they don't want to back it up, right? But if they are just sort of making this mistake, it really seems like we're building devices that don't have sufficient trigger guards on them, right? I mean, if you had a gun without a trigger guard, it's a really bad idea. And so what are the things over the next couple of years that will make things simpler? I mean, you can build process around these sorts of problems. You can build technology to solve these problems. I mean, flow control and Ethernet is arguably an example of this, right? And similar things exist in storage. What are the things that are going to make our lives better in terms of these technologies and techniques?
So my wife always says this has been designed by a man. So I think we need more women.
Not going there either.
Yeah, pass on that one.
Yeah.
Please don't retweet that.
We're not videotaping now, are we?
You're actually being broadcast over the internet, I think.
Which will be stored on YouTube.
Yep.
We're screwed.
There's been a lot of advances in interacting with computers, like multi-touch. People are doing great things with Wiimotes, the Kinect. Any of those tools have you seen, or do you actually want to see in a sysadmin toolkit? Like, we primarily use terminals. Is there some other way you'd like to interact with data, from a sysadmin's perspective?
I tried shouting, doesn't help.
Not always.
So I saw an interesting display that Microsoft had at Supercomputing this year where they had Kinects wired up to data visualization. And, Kris was talking about how we're collecting more and more data to try and make sense of our systems and try to quantify them and so forth. And I think that those sorts of approaches are going to start to become really important in the next couple of years. I don't think that they're going to be pervasive, but I think that when you have large quantities of monitoring data, you need to be able to understand it, you need to be able to interact with it and visualize it and find the areas that are interesting. And tactile kinds of interfaces or motion interfaces, I think, are going to be an important part of that.
So that's a good point, actually, from a different tack, though. In my earlier talk, one of the things I pointed out that I'm working on is a bandwidth assessment in the Ethernet community. And one of the common themes that we've heard from people bringing data in is that the data the data is coming in so quickly and ramping up so quickly that the monitoring tools themselves aren't doing a good enough job.
Well, we've seen this with security in the network space, right?
So I think that's going to exasperate itself as we don't solve the current problems and then throw more types of data at it to try to make sense out of all of this stuff.
Yeah, absolutely. And there are other kinds of sensors that are producing exponentially more data as we figure out how to build them better. And just dealing with those volumes of data is very difficult, both from the perspective of movement as well as analysis and storage.
Yep.
So I think that, so we've been talking about a lot of incremental things. What are you guys most excited about in the next, I mean, maybe even push it out to 3 to 5 years? What's going to change the way that the world works? I know, Kris, you don't think that the world is it's just going to equalize, but what's the world going to look like with high bandwidth networking and pervasive high IOPS storage? You know, we're going to be walking around with petabytes in our pants. Like, what?
Yeah.
We're
losing our audience
now. Is this what you're trying to go to? You know, I unfortunately want to pour some cold water on this. So, not that particular thread. Thank you. But so here we have these really nice processors. You know, people say, "Oh, it's like a Cray from 1984 or something like that." Well, that's just the processor speed and the memory speed, and it's really pretty incredible. Even the amount of storage on it is really pretty amazing. The trouble is, at least in the U.S., we have data caps. So when it would make sense, when you really, really want to search or do something that's really data intensive, you have to do it out in the cloud. But you can't take the data off your phone and send it to the cloud because you have this data cap. So it's forcing, we have something that's imposed on us by our carriers just in the US, not in Europe, where they don't have these data caps, because they have better infrastructure. And what they're enforcing is local computation, not computation in the cloud, because you can't move data back and forth. So I see somewhat a dimmer picture. You know, I don't see like even advancement around the world. I see places like the US where we're not doing as well. And to me, it's scary.
So
I live in Europe, so.
Yeah, I know you do. Exactly.
Is it nice there?
It is. Same weather as here, so.
Well, so, you know, I think that there's a lot of motion now in terms of the carriers trying to figure out what to do about this. And there's a TV commercial that I can picture that I think is maybe a Sprint ad where they're talking about data caps. Mm-hmm. And that's starting to become a competitive point. And I hope that becomes, you know, a more common sort of competitive tactic over the next couple of years. Though, I don't pretend to understand those things.
Yeah, well, people hit their data caps hardly doing anything at all. I mean, the phone is already chatty. And we just had the carrier IQ thing where anytime you're using your phone, you're using some of your data allowed. It's for the phone companies to sniff on your, you know, to essentially pay attention to your behavior on your smartphone, which, by the way, in Europe, they don't have. You know, this is another American thing.
Well, you know, and I think even more than that, the radio technology is getting better. You know, I just got a new phone, and it connects at 40 megabits. Mm-hmm. I mean, that's an awful lot for a device that's in my pocket.
Okay. Well, let's talk about a different future. I got up a little while ago because you were saying, what about green computing? And then you changed the topic, so I sat down again. If we wanted green computing, then we wouldn't have Hadoop and Cassandra and HBase all being written in Java. Okay? Because they're, you know, Jacob was joking about his mother writing in assembler, right? Well, instead of writing in assembler,
joking.
We're not even writing in C. Excuse me?
Oh, I wasn't joking.
Oh, sorry.
No, I was joking.
Anyway. No, actually, I thought you weren't joking because, you know, Bill Cheswick's mom was writing device drivers, so. But that explains Bill Cheswick.
Yeah, my mom doesn't even know what a device driver is, trust me.
So if we're really going to be doing green computing, let's switch this over a little bit. So I was talking to Adrian Cockcroft, who is some technologist at Netflix, and they've made this huge move to the cloud, right? They're actually getting rid of their data center, and everything's written in Java. And I said, excuse me, but why Java? And he says, because programmer productivity is amazing in Java. I asked Margot Seltzer, I said, Java, I mean, isn't there a huge performance issue? She says, well, yeah, it's not so bad. It's only about 50%. And so, there's a huge number of megawatts of power that's just going to programmer productivity. So our issue right now is that in order to make machines humanly usable, we have to waste half of our computing horsepower. That's really, I think, one of the issues going forward. Now, maybe there's a way of making Java so you could use it so it's not an issue. Even worse, do you know what one college professor at Harvard discovered when he gave intro to CS students? He said, okay, do these projects, pick whatever programming language you want, I don't care. Which language do you think they used?
Fortran?
Go ahead. Anybody else on the panel?
Basic?
Clojure? I'm hoping for Logo.
JavaScript. JavaScript by far was the most popular language. I just said, anyway. So we have the problem of interpreting. We want to have greener computers. We can't have people writing in JavaScript.
Well, I think that this isn't an issue that occurs in isolation, right? The trade-off that all these people are making is that, people are expensive.
Yes.
And computers are effectively cheap until you're running at large scale, at which point, it's going to be a real problem.
Yeah, I bet you don't run your HPC systems in Java.
Not so much, no. But I wouldn't advocate that the rest of the world write their apps in Fortran either.
Right.
So, this is a complicated trade-off, and I think part of the problem is that the costs of power, while they're an issue, they don't dominate enough to justify, right? I mean, if you think about a programmer that costs $200,000 a year once you load their salary and benefits and all that sort of stuff, $200,000 is an awful lot of power.
Mm-hmm. Yeah,
right?
It's a lot of servers too.
And
sure.
Yeah, I mean, you start adding up those costs, and it doesn't. I mean, we all sort of want to consume less power, but until there's a big financial incentive to do so, I think a lot of businesses aren't going to do it. And I mean, I can't believe I'm doing this, but in some defense of Java and JavaScript,
sure,
they've gotten better.
Sure,
I mean,
it's
not as bad as it used to be.
Mm-hmm.
So everyone realizes here, as a hardware engineer, how much I'm loving this conversation.
Okay, thank you.
I can actually follow up on that point a bit, coming from AMD, and I think that the hardware industry, and certainly the silicon design industry, designing microprocessors, that very question is what we're trying to solve in that industry right now. I mean, you have programmers that want to use further abstracted languages. They're putting more overhead. There's more stuff to do to get a given unit of work done. And in order to make that an effective trade-off, you need more processing for less power, so that you can do that translation. So that's why, frankly, both Intel and AMD, we're headed in the same direction effectively. We're providing more and more compute capacity per watt over time. I mean, despite Moore's law, we're still driving that wattage per unit of work down, so that the next generation, you can use Java for the same amount of power as you used C a few years ago.
There's some speculation that basically flops per watt is descending at a similar rate to Moore's law. And so this is hopefully a trend that continues.
Well, I wanted to challenge the Java inefficiency a bit, because I have a colleague who's studied that basic issue in detail. And the conclusion is that it's not Java that's actually the thing costing power. You can JIT Java. You can do just-in-time compilation, just like you can do just-in-time compilation for J#. That will give you back the execution speed, but what it does not give you back is a storage model. Because a storage model in Java is so powerful and so error-free in terms of normal use that it actually costs you a great amount in terms of garbage collection, and you can't JIT that away. So we're not talking about 50%, because 50% is not the baseline efficiency of Java. It's more like 30% or 20%. But the frank truth of the matter is that 20% is not going away because it's dealing with a powerful storage model. I might add that my best friend's 10-year-old, his native language is PHP. He's learning Perl. He's running his own net, and he's running his own service within his house.
So it seems like we've strayed pretty far from the original topics. So, I think that it's sort of funny in the HPC world. You start talking to hardware people, and there's all these interesting features, and then everybody walks out grumbling that the software is where the hard work is, right? And how? I mean, not to disparage the work of anybody on the panel, right? But there's I think that there's a complicated relationship between the hardware and software. And this applies to networks, and it applies to storage just as well as it applies to CPUs and memory. Do you think that we're going to end up in a sort of a commoditized situation that it seems like we're more or less in now? Is that going to continue in terms of storage and networking? Or is there going to be tighter integration, again, between these technologies, either because of performance or power consumption or any of these sort of emerging issues that are going to start to become, I think, real serious hurdles in the next couple of years?
You want to go?
Give me an API.
I'm hardware, so.
No, to manage your hardware.
I'm at a physical interconnect level. I'm not dealing with hardware at that level. One thing I did want to ask you, though, I was at SC11 as well, and there was a recurring thread that I was hearing from multiple analysts there. IDC, was it IDC or Gartner, had a morning presentation where they did this talk as well, which basically just said that the needs the development of hardware is outpacing software. And I was hearing that across the board from everybody.
Yeah.
I think we are seeing a need for commoditization just to get the basic cost, to keep that cost down. If we move back towards the proprietary model, it doesn't help us with the cost implications. From an Ethernet perspective, we were showing 10 and 40 gig working seamlessly together in the Ethernet Alliance booth. And I was kind of amazed that at an HPC-focused show, the analysts were blown away by the fact that we were actually focusing in on interoperability and not the latest, greatest speed, right? And they actually liked seeing, wow, this is real technology now. You're demonstrating that we can actually use this because you know what? We don't have as much money to buy this stuff as we thought we were going to have. So knowing that this stuff is working, and obviously 40 isn't 100, but they were happy to see it because this is a real tool that they can now use. So I think that, forget the commoditization, it's the cost. And yeah, that's going to continue, if not grow, to be a greater and greater need.
Well, I think one of the things that you picked up on at SC was that I think that people in the HPC community have realized over the last 10 or 15 years that the thing that we're the best at as a community is putting companies out of business. And so we can't sustain independent development of this stuff. And as nice as it is to build a Ferrari, it's expensive to build a Ferrari, right.
Apologies if this was addressed earlier because I stepped in late. 2 questions. Wireless USB, broadband high speed, what's going to happen in the wireless networking space that's going to be high speed? And where's my holographic storage?
Well, I can answer the holographic storage. It was the most recent commercial iteration was sold off at a auction, I believe in Colorado a couple months ago after the company failed to pay their taxes and failed to pay their rent and failed to pay everything else. And they made this really gigantic device that, you put a little disk in and held a couple of terabytes. But, maybe someday. There's been a lot of talk about it for a long time. But it seems that every time somebody comes up with an interesting optical technology, the magnetic technology leapfrogs it and stops looking interesting again. The part that was supposed to be interesting with holographic storage was that it was supposed to offer a pretty convincing long-term reliability without having to power it. So removable media that didn't rot over time. But, again, like anything else, getting it to market. Optical vendors just have a bad habit of going out of business after a while.
From the wireless networking, I'm not sure what the latest efforts are. What I can say is that at one of the meetings they provided a tutorial on, we can do 100 gig over wireless. So I think there's I won't comment on it. I wasn't able to attend the tutorial. I think, though, there was a level of not serious perceived with it. But I do think there's continuing pressures between both wireline and wireless technologies to try to keep up with each other.
You can probably also pop popcorn with that device.
I wouldn't keep that on my body.
So, in a more sort of short-term vein, what are the things that people in this room can do to prepare for the technologies that are emerging now that will become pervasive in the next couple of years? What are the technical topics that they should be starting to learn about? What are the sort of wrinkles compared to previous iterations of these kinds of technologies? Where should people be spending their attention?
So what I'm always saying is talk to your vendors, ask APIs, ask open standards so that you can actually build on top of those things. And, well, you're the consumer, so you're the ones who's deciding whether you're going to buy or not buy a specific piece of hardware. And you have the power, use it. And people starting to do that because it's your pain you're going to solve.
Yeah, I think from an infrastructure interconnect perspective as well, you need to be familiar with what the capabilities of the different standards are. There's some competing standards out there where they make claims, and when you go and you look at what they're actually talking about from an optical budget perspective, you realize that, oh, I can't throw this into my network the way that I wanted to because it doesn't have the right needs optically from a budget perspective. So you're going to have to either become versed or get people who are more versed in how all the interconnect stuff actually can work and interconnect together when you're laying out your data centers or whatever.
Well, I mean, when it comes to storage devices, planning for the future, it helps just to start by knowing what you need. I find most sysadmins actually don't have that much perspective into what the demands are of their storage systems. And then after that, there are a handful of vendors that try to accommodate rolling upgrades of your storage systems over time, but more likely you'll wait until the technology feels ready, and then on your next big refresh, you'll buy the next big thing.
Okay. Well, I think,
This is sort of a Jacob hardware question, but what affects like Thai flooding or Japanese tsunami or sort of our supply chain for these things is really, really vulnerable, and people are realizing that. Do you think that may change in the future? Or?
Well, I'm not really an expert on the supply chain, other than Thailand is a couple feet underwater, and we don't have any hard drives. And then I think there was another issue with tape media shortage that came after the tsunami in Japan. It would seem that we are increasingly dependent on a smaller number of vendors. And here I'll just bring it all back. When you're on a panel, you got to keep hanging on to what you said at the very beginning, or else somebody will pick it out later and talk about how you're inconsistent. So I'll bring it all back to solid-state storage. I think a bunch of folks that I know in my industry are talking a lot about how this Thailand flooding, may really bring about the solid-state revolution that much sooner, because it turns out that the barriers to entry to manufacture solid-state devices seem to be much lower than those to manufacture hard drives or tape media. Like, they're very specialized vendors and factories in those ecosystems. Whereas it seems that anybody with the right clean room and the right chip makers and whatever else could potentially fabricate solid state. So it very well may be that as the marketplace for SSDs heat up, there will be diversity in that supply chain. It'll be a lot easier for multiple vendors to play, and that might bring about the commoditization that much faster too.
Yeah, but that you raise an interesting point that I was going to make, but not in the positive way I think you were. You're seeing a lot of the fabs moving offshore, and in some cases a lot of consolidation that brings up the very issue. TSMC, for example, is one. I run into a lot of vendors that use them. What would happen if their fabs were hit by whatever? I don't know enough about their supply chain, how much backup they have, but fabs are not cheap. You guys all hear that. So as the investment in fabs goes and gets consolidated, we run into those sort of problems. We need to have and make sure there's a worldwide supply, that you're not ever in a sole source position, that it's a problem. And that goes for materials as well, right? You heard about that, as well as some countries owning a lot of the rights for some of the minerals and some of the things that are specifically used in these next-gen chips.
So I think if there aren't any more questions, we need to thank our panelists for painting a picture of the future.